Alright, got a couple examples here of some quadratics. One of them is in standard form, the other one is in vertex form, and I want to talk about solving. In particular, I want to talk about how to find the x-intercept or intercepts and the y-intercept. Okay, so recall that the x-intercept is what happens on the graph when you cross the x-axis, and on the x-axis y has a value of 0. So we can find those by plugging in 0 for y. So here it's really difficult to solve for x. You can't just, subtract 2 from both sides. And then, what do you do now? How do you get the x by itself? Well, it doesn't work that way. Instead, what you have to do is you have to try to factor this quadratic down. So this will factor as x plus 2 times x plus 1. And then there's this rule in mathematics that says that if you have two things that are multiplied together and it equals 0, then one of those things has to be 0. Or technically they could both be 0. So you can split it apart and set each one equal to 0 and solve it that way. This is called the zero product rule. It only works if it's equal to 0. So if I had this same factor thing and it was equal to 3, I could not split this apart and set each one equal to 3. This doesn't work that way. But if it's equal to 0, we can do this. So we get one of them is at negative 2, 0, and the other one is at negative 1, 0. Okay? So that's the x-intercepts. We can also find the y-intercept really easily when it's in standard form. All you gotta do is plug in 0 for x, and you see that it's at y equals 2, so we get the point 0, 2. Okay, so that's 3 points that are on this graph, and they were all three pretty easy to find. So standard form is pretty nice for finding x-intercepts and y-intercepts. It's really easy to do as long as the thing factors. If it doesn't factor, it's a little bit nastier because you have to use the quadratic formula. You know what? Tough luck, I guess. So vertex form is a little bit more unique. So here the idea is, well, we still want to start off by setting y equal to 0 to find the x-intercepts. And then we're going to try to solve for x. So notice that this equation doesn't have a linear term, which is kind of what messed us up over here. We had that 3x that made it really hard to subtract 2 from both sides, try to solve for x that way. And if it had just been an x squared, it would have been a little bit easier. So here we have just the x squared and the numbers. So this one works out to be a little bit easier to solve. So one thing we can do here is to start off is to add 2 to both sides, and then divide by 2 on both sides, and then take the square root on both sides. And the square root of 1 is 1, and the square root of x minus 3 squared would be the absolute value of x minus 3. Some teachers will skip the absolute value part and just say that x minus 3 would equal plus or minus 1, which is technically true, but the reason that it does that is because the square root of a variable squared is always the absolute value of whatever you were squaring. So we get x minus 3 equals 1, or it equals negative 1. Here if I add 3 to both sides, I get x equals 4. And here if I add 3 to both sides, I get x equals 2. So those there are my two x-intercepts for this graph. I can also find the y-intercept, and again it's found the same way. You're just plugging in 0 for x and trying to solve for y. In this case though, there's a little bit more work when it's in vertex form. So here 0 minus 3 quantity squared would be positive 9. If I multiply that by 2, I get 18, and then subtract 2, I get 16. So my y-intercept would be at 0, 16. So not quite as easy to find the y-intercept when it's in vertex form, but nothing super challenging here as long as you understand the order of operations. Alright, let's go through 2 more examples here real quick, and then we'll stop. So y equals 2x squared plus 5x minus 3. And y equals negative 1 x plus 2 squared plus 9, we'll say. So number 3 here, again, let's start off by finding the x-intercepts. Remember, that's when y is 0. So we want to try to factor this thing and see what happens. Let's try 2x and x, and 3 and 1, plus and minus. So 2 times 3 would give me a 6x, minus 1x is the 5x that was in the middle, so we know that this works. So then you can split it apart and set each factor equal to 0 and try to solve for x. So x would be a half. So we get one of them to be the point 1/2 comma 0, or x equals negative 3, which would be the point negative 3 comma 0. And then the y-intercept is, again, when x is 0, what do you get for y? And it just comes out to be negative 3. So we get the point at 0, negative 3. So there's 3 unique points that are on the graph of this quadratic. Worked out great. Pretty easy to find them in standard form. Let's look at the vertex equation. The x-intercepts, again, are when y is 0. So we're going to go through and try to solve. So we'd subtract 9 from both sides. And then divide by negative 1 on both sides. And then square root of both sides. And I'm going to skip the absolute value step because I understand it. Your teacher, if you're showing your work on your paper, you might want to write the step in the middle here. Absolute value of x plus 2 equals 3. Some teachers will count off if they don't see this. At least at my school they do. And then, so we can split this apart and say that x, if I subtract 2 from both sides here, x would be negative 2 plus or minus 3. So one of our solutions would be negative 2 plus 3, which is 1. The other one would be negative 2 minus 3, which is negative 5. So there's your 2 x-intercepts. Again, it's a little bit more work to solve for them when it's in vertex form. Not impossible though. The y-intercept is when x is 0. So you plug in 0 for x and try to solve for y. So 2 squared would be 4. Times negative 1 would be negative 4. Plus 9 would be 5. So it would be at 0, 5. Okay. So there's 4 examples of how to solve a quadratic equation and find the x-intercepts and the y-intercepts. All of these have worked out nicely. I'll make another video where they don't, and I'll show you what to do when your standard form doesn't factor, or when your vertex form comes out nasty. So look forward to that one. Good luck.